Hello, I'm Mark Haynie and I'm the Dryer Product Manager for Novatech.
And I'm Tim Noggle, the Senior Vice President of Sales for Novatech. And welcome to Drying Secrets for Producing Defect-Free Products. We hope this is informative for all of you, and we appreciate you taking time to be here with us. So the first dryer we're going to talk about is Novatech's offering for the micro molding and micro extrusion process, specifically related to medical, which is, as we all know, proliferated this year because of the medical pandemic that we've been going through. Our offering is the NDM5 NovaDryer Medical. It's based on our NovaDryer technology, which is a membrane technology that generates -40 dew point air. And it's very simple in operation. It requires a 110 volt outlet, a single air line with 80 psi of air running at about 3 SCFM, and it's a very simple on the feed throat application for most resins. Mark, do you want to talk a little bit about the specifics of the technology?
Sure. First, this is all based on our membrane technology. With the membrane, we ended up having a performance of a desiccant type based system without any moving parts. So in this, you'd put compressed air on the bottom at saturated conditions, and that's unique to us. Most of our competitors require you to pre-dry the air before going to the membrane. So with us, you can take air directly from a compressor without pre-drying, put the compressed air in the bottom, have -40 air come out the top. The system we've produced uses a stainless steel hopper. This is a 20-pound hopper. We have a HEPA filter at the top so that it can be located in a clean room. It has handles on the top and bottom so it can be easily moved and can mount directly on the throat of the extruder or the injection machine. So Tim, I think we have a pretty easy system here. And the control system, you were going to look at the control system a little bit?
Sure, absolutely. And one of the things that we wanted to point out is the control is actually a pendant type control with a 12-foot umbilical. And so this can be easily mounted down at the operator level. Obviously this extruder, being a small medical extruder, has a very low height of the feed throat. But on larger machines or on a machine that may be a wider base, sometimes it's not quite as easy to reach right to here. And so this can be mounted anywhere that's convenient to the operator. So that's very simple for them to get to and use, and so that they're constantly monitoring what's going on with the dryer.
So what does it take to change the temperature when you have a resin change?
So the great thing about this dryer is it's nothing more than plugging in the dryer, plugging in the air supply, and then setting the temperature on the pendant controller, and then turning the unit on to run.
And I'd imagine that since the compressed air coming into this is also already at a relatively low temperature, this would probably be a great dryer to use in low temperature drying applications.
Well, absolutely. I mean, this dryer will run as low as the temperature of the incoming air, as you said. So unlike desiccant dryers that many times have a regeneration temperature issue, so your minimum may be 140, 150, 160 degrees. With this dryer, if you have air coming off of your plant air system that's 70 or 80 degrees, well, that's your minimum drying temperature. Probably not going to be the one that you dry at, but certainly 120, 130 degrees would be a very simple process to manage.
So it's not affected by heat coming off a blower or something like that?
Absolutely not. So one of the unique features of this dryer also is the fact that it is a modular design that's easily removable. Because of that, Mark, why don't you show everybody how simple it is to pre-dry resin in one unit and be running resin in another unit and then swap.
Absolutely. If you're going to have a resin change, instead of having downtime at the machine, what you can merely do is have a second unit pre-drying the resin here, and it's as simple as taking the latches off, removing one hopper to another, and now the resin that's been pre-drying is in process now, and you're able to start producing again on the extruder here or an injection machine immediately. There's no downtime because you've already pre-dried the resin. All you did is relocate the hopper. So now we want to talk just a little bit about what it is to hook one of these things up to your plant. It comes complete with a typical wall plug type system. You just plug it in and that's all the power that it needs. You would hook your compressed air from the plant up to these. There's a quick connect here. There's a valve in order to turn the air off when you're not using it. The first filter in here is a 1 micron filter, removes almost 100% of the particulates. The second filter is a 0.01 micron. It'll filter down to 1/100th of a micron efficiency. And this is to remove any aerosols of oil that may be in your plant air. There's a connection here to check the pressure of your air. We need at least 80 psi on this in order for it to be operating properly. The filters in here are only changed once a year, and that's really the entire maintenance of this unit.
So we've talked about our micro drying application and how it's related to medical molding and micro molding. Now we'd like to talk a little bit about difficult to dry resins, specifically related to resins susceptible to oxidation, such as nylons, PBTs, TPUs, and those types of resins. They become more and more prevalent in today's market, and because of that, we've developed a very unique drying solution that helps to address the concern of oxidation and oxidative breakdown of resins, as well as discoloration of resins in highly sensitive applications that require great clarity or color distinction in a process. Mark, you want to talk a little bit about the dryer that we have standing next to us here?
Sure. This is our NDN, the Nova Dryer Nitrogen. And as you can see, the membrane in this is considerably larger than the membrane we had in the other system, because instead of just removing 0.9% water from the airstream, we're removing now 20.9% oxygen, 400 parts per million of CO2, and the 0.9% water. So we end up having a dry nitrogen product from this unit. So this is a two-stage type system. And each of the systems has the temperature control for it. Typically, if you're drying nylon at 180 degrees, each of them would be set for 180. We're going to put the first stage of dry nitrogen, comes into the bottom of the hopper, and begins to pass up and do the drying process. Also, we have a second stage in this one that makes this system much more efficient. We don't just vent off nitrogen at the end of the process. Once the nitrogen reaches the top of the hopper, we take most of the nitrogen that's released at the top of the hopper, and really this is like still minus 20 degrees Fahrenheit dew point, and we bring this back through a filter, back in with an air aspirator, and that air aspirator once again has no moving parts. There's no blower or anything in there. So we're using just a small amount of compressed air as a power source to remove most of the nitrogen at minus 20, bring it back in, reheat it, and reintroduce it back into the hopper. So about 80% of the nitrogen is recirculated and does both drying at the bottom of the hopper and drying at the top of the hopper. This membrane, once again, it takes in just compressed air. We don't have to supply nitrogen to this unit like competitive units. We take in compressed air. We take in compressed air, we remove the impurities, including oxygen, and therefore this membrane releases oxygen at the membrane. We release nitrogen here. So in the end, what this system does is it takes in compressed air and releases just air back into the environment. So this system is capable of being placed in an area with employees, and there's no chance of the employees being exposed to a nitrogen stream or nitrogen contamination. This system works based on the relative permeation of gases through polymers. It's much like the fact that The airline industry uses nitrogen in tires rather than air because nitrogen permeates through the rubber in the tires much slower than the oxygen that would be in the air, and therefore the tires stay inflated much longer. Using that same principle and the polysulfone fiber that's used in this, the water passes through the fiber very, very quickly. The oxygen and CO2 pass through at a slightly lower rate, but still relatively quickly. And the nitrogen passes through the fiber very, very slowly. So over the course of passing through the fiber, the water leaves first, the oxygen and CO2 leave second, and then the nitrogen comes out as a product gas stream.
So that's an interesting point, Mark. One of the few dryers that you can actually have co-located with employees or in a clean room type environment, and yet you're still not concerned about outside contaminants or highly concentrated nitrogen creating an unsafe situation for employees.
Right. All the competitive pieces of equipment require you to bring in dewars or nitrogen bottles. Sure. And then, yes, you can have a nitrogen dryer, but you're taking in nitrogen from a nitrogen source and releasing nitrogen into the environment around the employees. This particular product takes in air and releases air. So it's safe to be in any environment at all with the employees.
Certainly a much safer and easier to deal with situation.
And also compressed air is available just everywhere.
Absolutely.
Nitrogen's not. You never run out of compressed air in your plant.
Yep. Well, so we've talked now about oxidative breakdown of resins, and this is a great solution for that challenge that most molders and extruders face on a lot of the engineered resins that are starting to proliferate within the industry. But there's also an age-old problem and an age-old concern of thermal breakdown and overexposure to either temperature, airflow, or excessive dew point and excessive drying of that resin. We've got another interesting product that I think we'd like to talk about. Mark, let's move over here and take a look at this product.
Sure. So now that we've talked about oxygen breakdown in systems, we're going to talk about the thermal plus dryer. The thermal plus dryer has the ability of changing temperature and dew point in the airstream.
So Mark, is this dryer based upon the same technology we've been talking about with the Nova dryer, or is this something completely different?
No, this technology is based on a desiccant wheel, which is a wheel impregnated with desiccant. The desiccant is a molecular sieve, like most of the desiccant type dryers that are out there right now. It's embedded in a wheel. The wheel rotates on about a 10 revolution an hour cycle and is able to produce -40 above or below type dew points as necessary.
So we've talked a lot about maintenance on the other dryers. Is the maintenance fairly simple on this as well, or is this more complicated?
First, this wheel will last typically 10 to 15 years. The wheel is going to last a very, very long time. Mm-hmm. There are some moving parts in this. We do have some blowers and some things like most desiccant type
more
dryers. Traditional drying systems. But everything is very simple. Everything's very accessible in here. And you can get in and do the maintenance on these systems very, very easily. We produce this system in a few configurations. The one you're seeing here has most of the feature of what we would call our DC. The DC includes the ability of loading the hopper, loading the machine. We have a convey blower down here. The convey blower is used to operate all the conveying systems. The filtration for the conveying system here. The drying hopper has a purge valve on it. So we not only to the machine, we purge it with dry air consistently, and that stream ensures that there's no contamination and nothing sits in the line between the dryer and the machine.
So no reabsorption of moisture
Absolutely.
here in the process. Okay.
Some of the advantages of this piece of equipment over anything else out in this is it includes what Novatech refers to as Moisture Manager. Moisture Manager is unique to Novatech. What we're able to do is we're able to take a sample of the air in this drying hopper. You'll put your dry air in the bottom, If the resin, for instance, nylon in the wintertime, when it has very little chance of picking up moisture, you'll take it out of the bag or the Gaylord, and it's already dry.
Okay.
So what this will notice is that by the time you get up to some level in this drying hopper, it notices that there's been no change in dew point. It does not need further drying. One of the problems with over drying is you have typically a fixed hopper, a fixed temperature, or even if you have something like temperature setback, you don't know at any point in time that whether or not that resin is giving up moisture or not giving up moisture. This product is unique. We find out if there's moisture being released from the resin. If so, we don't continue to process it with the same -40 air. We move to lower purity airs that have the ability of not taking more moisture out of the resin.
So if the conditions of the resin or the conditions of the environment change, the dryer recognizes that and changes with it.
Absolutely. If you happen to have a Gaylord that you've been running out of, and it's been sitting in the room for a long period of time, and it's picked up a lot of moisture, it may be using a fair amount of -40 air to do the drying in here.
Sure.
However, you bring out a new Gaylord material. This is very, very dry, and you have the chance of over drying it and making brittle parts. This will notice that and reduce the dew point of the air going into here, and also the temperature of the air. That's the reason we refer to it as thermal plus. It changes the thermal aspects and the dew point of the air to remove just the amount of moisture necessary and no more.
So Mark, show us how that all works. There's obviously technology involved.
Right, so there's a valve in there that will alternate between dried air and undried air. There is the moisture sample being taken out of the top. We will monitor both this moisture sample and we'll also monitor the dew point being produced in the desiccant part of it. And it will find a median on its own automatically where you don't over dry the resin.
Gotcha. So this extra tube that I'm seeing here is actually the moisture sampler?
That's the moisture sampler for inside the hopper that determines if there's moisture being released from the resin.
Okay. So Mark, that was a great explanation of how the technology works and the aspects, the specifics of the technology. But what does the operator see? What's the operator interface and how simple is this machine to work? Because it seems like there's a lot of complicated things going on.
First, this is all with Siemens PLC and a color HMI high definition. The HMI faces right at a perfect level for an operator to see. A simple on-off system to turn it on and off. It's very, very simple too. If you wanted to change a resin, you would merely touch the resin, touch the other resin, enter it, and press run, and the other resin now would be back into the system. You can either change it by the resin menu or just entering a temperature that you'd want to operate at. It shows you the return dew point. It shows you the processing dew point. All the filtration is in the front. So all of your access points are in the front of this unit. You shouldn't have to try to get into the back. All three filters, the HMI, the on-off, everything's located where somebody can get to it easily.
So are there any adjustments or set points that the operator needs to deal with to make all the thermal plus aspects of this machine work?
That's one of the really unique things is almost everything in this system occurs automatically. Once you select your resin, it will try to see that that resin is not over-processed or under-processed at any period of time. You have your resin menu, you have a recipe. The recipe tells the machine what you want to operate at, and it does this all automatically without any operator intervention.
Well, that's great. And I think being as straightforward and simple as we can with those types of technologies makes it usable for all types of operators and doesn't require us a processor to have a highly technical engineer standing out at the machine trying to make these wonderful technologies
Anybody
work.
that could be an operator on a processing piece of machine, this can be introduced to them and there's really no training required.
Oh, that's great. So all of the technologies we've talked about thus far have really been centered around press side or single dryer to single machine or single resin to single dryer type of applications. But many of you have challenges in your plants such that you require multiple machines with multiple resins or many changeovers in a day or in a week where you need to have multiple resins either drying and running or pre-drying and getting ready to run. That really calls out the need for a central system. Mark, why don't you talk some about central drying systems and how that really goes to the heart of the subject we're talking about today in terms of consistency of process and better product quality.
Absolutely. When you start having a lot of changeovers in the day, when you might be changing the color, you might be changing the mold, and you don't want downtime. You want your productivity of your machine to be maximized. You don't want a downtime associated because you have to pre-dry the resin before going on stream. When you move to a central type system, you can have hoppers, many hoppers in the system. It can be whatever your next resin is that's getting ready to run. So say you're making the same part, but you make that in several colors for different customers. You can be ready for that change. You don't even need a mold change. You can switch quickly from one product to the next product. If you actually have a mold change, it might take you a half an hour in order to change the mold, but it could take you 4 hours to pre-dry the resin for that mold. So if you go to central systems, and I love central systems, they're able to take and allow you to make the most of your system and keep production of your machine. So if you look at this system, this is a simplified version. We only have one dryer and one hopper, but you can see from the HMI here, we're showing multiple systems operating off of this. So in the bottom, we have everything very easy to use in these systems. You would press, so you wanted to go to the hoppers. I want to look at that hopper. Your overdrive protection, your alarm set points, your set points. We even have a pre-dry in here. It has a countdown timer. The countdown timer will see that somebody in your plant doesn't start pulling from that hopper before the resin and it's ready. But maybe sometime there was a time that you had a power outage. The resin in there is dry. You don't want to have to wait another 4 hours to go into production. You merely can press that, it unlocks that hopper and allows you to go into immediate production. We trend all of the data either from the central dryer or what we call the CDA, the central dryer assembly. We have all the alarms of this system logged. This screen will tell you how the operation of the wheel is going, whether the properties are proper, and home always takes you back to where you're going. It's easy to get back to that point.
So Mark, you mentioned a feature that we really didn't elaborate on, but I think is interesting and would be interesting to all the folks watching this presentation. Talk to us a little bit about overdrive protection and what that really means.
Overdrive protection, and some of our competitors use a term of temperature setbacks, and ours is similar to that technology, but it's more advanced. In temperature setback, typically you'll know that you're drying at 250 degrees, maybe with a polycarbonate, and based on that, you would normally expect something about 130, 40 degrees coming out the top of the hopper. If you start seeing that temperature elevate, then it says, well, you have the ability that you're putting in too much energy. Maybe the mold size is less than you've designed for. Maybe there's less moisture on the resin today. And the overdrive protection both protects the property of the resin and saves you on power. True. So what we do, though, instead of like in a temperature setback environment, instead of just saying, hey, at this temperature, set back to this temperature, we know from experience what the temperature should be at the outlet. So we find we have the system find the temperature it should be operating at without the operator having to become involved. If the operator has to put in those values, I can tell you there's not an operator out there that would know what to put it in.
Sure, it's not something that the normal person operating a machine really has the background or the experience level to just choose something at random.
Not even many of the people in our industry could tell you exactly what temperature you should start at and what you should set back at. We've used the fact that we're the dryer company. We should be the experts. We should be the one that has the system operating the way it should without an operator becoming involved.
Makes sense, makes sense. So Mark, we talked about the dryer, which is obviously the heart of the system. It generates dry air, it manages the process, and it's a very important part of the whole process in drying. However, talk to me a little bit about the difference between this drying hopper behind me, which is a central drying assembly hopper, and the hoppers that we talked about earlier, the single hoppers, and why those are different, how they manage the process differently.
Absolutely. And one of the things that happens in a central system is we're not just producing the air for this hopper the way we were in those systems over there. We're producing the air for a number of hoppers over here. And one of the other things that you always get involved in is how does that air distribute properly to each of the hoppers. So in each of our HB units, we have its own blower. We have a dry air stream leaving the dryer, and we have a return stream. Out of that dry air stream, there's a blower that picks exactly the amount of air that's sized for this hopper out of the dry air stream leaving the hopper and applies it to this hopper. So you can have any number of hoppers here. And instead of trying to have valves and things and make the right amount of air go there, we have a blower there that's sized for this hopper and will take only that amount of air out of the hopper. With this hopper, you can change the temperature here or through the HMI interface on the dryer. So if you wanted to, you could just merely go to here, change the set point, and change the set point on this hopper if the temperature were to change. But these communicate. The communication can be done here if you just happen to be standing at this location, or more easily, if you're near the dryer, you can change the dew point at that point.
So Mark, not all dryer manufacturers take the approach that Novatec does in using individual motors and so forth. But in general, all the principles are the same no matter what system you have. Is that correct?
There's a hopper. It's supposed to get a certain amount of air for the drying to occur, a certain temperature time. It's the same properties you run into all the time. Time, temperature, dew point, and residence time will tell you how long the resin is supposed to be in there and how it gets dried to the proper point.
So all the principles are the same across whatever system you have. It's just what the approach is to running the system.
Right, and instead of using some valves in order to try to see that the proper amount of air, we use a blower, and that directs the right amount of air to the hopper.
Okay.
Each of these hoppers, as you see with a central system, they all have a purge valve. Because what's very important in a central drying system is you don't leave resin in the line, so you have to have purge, and you maybe have dry air. So that hose coming in from the bottom there, that's the dry air convey to the machine.
Now I see this box up on top, and I know what this is, but the folks that are watching may not really understand what that is. Can you just give us a real quick snapshot on what this technology is that's sitting up here?
This is based on our Machine Sense. The Machine Sense will take and automate your system so that you bring all of your alarms, all your maintenance, everything that's necessary back to information, every information of things. We're trying to be able to have all information on the drying process available to the people all the time and use it to interface maybe with other machinery in the plant so that all pieces of equipment communicate together through the information of things. It can be cloud-based, it can be locally based, but the system provides that interface.
Well, certainly information is what we all depend on anymore to make our operations more efficient. And you know, the more information that the system can provide, I think the more effectively we can all run our operations and make better product. So through the magic of modern technology, we've hopped across the room. You'll notice that we're standing in front of a much smaller drying hopper than we were when we were over in front of our central drying area. And that's just because it allows us to show you the features and the benefits and the design of our high efficiency hoppers, which are what we use for our central systems in today, in a much easier, more manageable arrangement. So Mark, do you want to talk a little bit about some of the features and benefits of this hopper?
Absolutely. Once again, as we were talking about earlier, we want to get the air to the resin in the most efficient form. So we've developed a hopper that has very good mass flow characteristics, has a diffuser inside that distributes the airflow. So you have resin moving down the hopper very evenly, you have air moving up through the hopper very evenly, and that ends up giving you the best dry time and the best drying performance. So in this hopper, we've moved to improving to have borosilicate glass windows in here. In the past we had a polymer type window. Sure. This is a hardier window, plus it doesn't discolor the resin and gives you an actual picture of what the resin looks like. This hopper is very easy to get into. You merely undo the latches in the hopper. They're a new latch design that seals the hopper very, very well. We have a lance type diffuser on the inside. The lance has two positions in this lance. If you have normal, primarily pelletized material or something that's a normal type resin, the lower position works best. Or we have the ability of moving it to an upper position with this hopper if you happen to have some very problematic regrinds. Maybe things like some reprocessed material, ground up bottles from a recycling facility, but so all stainless steel interiors.
I'm sorry. So just to clarify from my understanding, if we are in the recycled position on the diffuser, we're giving up a little bit of efficiency, but we're doing that to be able to gain the flexibility of using any resin in the hopper. Is that right?
Absolutely. Okay. But what you'll see is the hopper size in that is all designed for these materials, okay, and they'll operate fine under those conditions. We have the two glasses in the front, all stainless steel interiors, mm-hmm, and very easy to operate, very easy to clean. A diffuser in the bottom, and clean out ports and sample ports in the bottom.
And these hoppers come in both a standalone version like this and in the central drying configuration that we saw over.
Absolutely.
Okay.
So thank you very much for attending today. Hope you've had a few things that you can bring to your plant to make the use of the polymers in the plant more efficient and to get the most polymer properties out of your equipment.
We've talked a lot about a lot of different technologies. We hope that some of what we've presented today can be helpful in you evaluating your process and determining whether there are some things you can do differently in the drying process, the molding process, and your business overall that may improve the bottom line of your company. Again, we appreciate very much the time you spent with us. We know your time is valuable, and we hope we brought some value to the time that you've spent.
Thank you.